Welcome to this explainer. Today, we're going to unpack the financial and technical blueprint for moving away from expensive cloud APIs and transitioning to your very own secure, cost-effective private AI server. We're essentially moving from an era of renting intelligence to actually owning it. And we're going to look at exactly how you can pull that off using the incredible hardware and software available to us in 2026. Here's our step-by-step blueprint for today. First, the cloud AI hangover. Then, why VRAM is king. Next up is choosing your AI hardware, followed by the core software stack, and we'll wrap up with automating your private AI. Let's jump right in. Starting off with section 1, the cloud AI hangover. This is really the catalyst for this whole shift. Relying on cloud APIs is literally like renting an apartment with endless fees and strict rules. Whereas running local hardware is like owning a house where you build equity and have total freedom. Think about it. With the cloud, every single prompt, every tiny piece of a word or token triggers a microtransaction. It's a recurring tax. Plus, your data is leaving your network, which opens you up to privacy risks, and you're entirely at the mercy of their rate limits and content filters. But when you actually own the hardware, sure, it's an upfront capital expense, but you get total data sovereignty, and your marginal cost to generate those tokens drops to absolutely zero. Well, okay, aside from your electricity bill, of course. Now, here's a stat that is just wild. For high-volume users who are spending over $200 a month on API tokens, local hardware actually breaks even in just 3 to 6 months. That is a staggering return on investment. Look, if you're barely using AI, the cloud totally makes sense. But if you're a developer, a researcher, or part of a team doing heavy daily usage, buying the silicon pays for itself incredibly fast. Let's put that into perspective over a 3-year total cost of ownership. Say you're processing a heavy workload like 1 million tokens a day. The math is undeniable here. Cloud APIs can easily drain $60,000 over 3 years, but a high-end local setup, even when you factor in the hardware, the electricity, and the management, it costs around $23,900. You're looking at a system that is roughly 60% cheaper over that time frame. It's a no-brainer. But beyond the math, this is fundamentally about security. It's about ensuring your proprietary code, your emails, and your client data never, ever leave your own local area network. As one of our sources perfectly put it, this is digital sovereignty applied to artificial intelligence. If you're in a regulated industry like healthcare or law, or you just really want to protect your trade secrets, keeping your prompts on your own local server isn't just a fun cost-saving measure, it's a mandatory security requirement. Moving right along to section 2, why VRAM is king, and understanding the memory bottleneck. If you've built traditional PCs before, honestly, forget everything you know. In the AI world, VRAM, or video RAM, dictates absolutely everything. The AI model's weight matrix, which is basically its entire functional brain, has to fit entirely into this space. If your model is too big and exceeds your video memory, it spills over to your much slower system memory. And when that happens, your performance plummets from a snappy 30 tokens per second down to an agonizing 3 to 5 tokens per second. So VRAM is the absolute bottleneck here. A good way to think about VRAM is like a chef's counter space. The size of the model dictates how much counter space you need to work efficiently. An 8 billion parameter model needs about 5 gigabytes. Step up to a 32 billion parameter model, and you need roughly 20 gigabytes. And if you want to run a massive GPT-4 class 70 billion parameter model, quantized to 4-bit, which by the way, shrinks its size with almost zero loss in intelligence, you're going to need about 40 gigabytes of VRAM. The takeaway here is that you absolutely must pick your hardware based on the largest model you actually intend to run. With our VRAM requirements locked in, let's look at section 3, choosing your AI hardware. Let's talk silicon. So in 2026, you basically have 2 main paths. You've got Apple's unified memory on one side for massive capacity and efficiency, or you've got NVIDIA's brute force dedicated VRAM for just unparalleled token throughput. Apple Silicon, like the M-series chips, uses a unified memory architecture. This means you can buy a machine with 64 or 128 gigabytes of memory, and all of it can act as VRAM. It's super quiet, very efficient, and perfect for a single user. NVIDIA, on the other hand, gives you dedicated memory bandwidth. It generates tokens significantly faster and is absolutely the gold standard if you're dealing with multiple concurrent users or if you want to dive into fine-tuning your own models. Ultimately, your budget dictates the model size you can run. If you're building a mid-range rig, a used RTX 3090 remains the ultimate value card right now, packing 24 gigabytes of VRAM. You can snag a used 3090 for about $700, and it easily handles 30 billion parameter models. Or you could grab a Mac Mini M4 Pro. But if you have the budget for a high-end desktop, Say dropping $3,000 to $4,000 on dual RTX 5090s? Well, now you suddenly have 64 gigabytes of VRAM. That gives you plenty of headroom to run those massive 70 billion parameter models locally at blazing speeds. All right, Section 4, the core software stack. This is how we bring all that hardware to life. The great news is the software ecosystem has matured incredibly fast. You don't need to compile complex code from scratch anymore. It really breaks down into 4 parts. First, traffic handles secure access, acting like a digital bouncer, keeping everything encrypted behind HTTPS. Step 2 is Ollama. Ollama is just incredible. It's literally a single command to install and run almost any open weight model instantly. It acts as your engine. Step 3, Open Web UI provides the chat interface, so you get that really familiar, polished ChatGPT-style experience right in your browser. And finally, N8N connects it all to your workflows, serving as the automation brain of the whole operation. Of course, depending on your scale, you might swap some of these components out. Serving dozens of concurrent users? Swap Ollama for VLM because it excels at continuous batching, letting it juggle tons of requests smoothly. If you're a beginner and just hate the command line, no problem. LM Studio gives you a beautiful drag-and-drop graphical setup. And for document retrieval, anything LLM is fantastic for small teams, while Onyx is the ultimate heavy hitter for strict, permission-aware enterprise data search, securely indexing your Slack, Drive, and Jira. And finally, Section 5, automating your private AI. This is where things get really exciting. This is the moment your private cloud stops being just a chat interface and starts doing actual autonomous work for you. By connecting your local LLM to an automation tool like N8N, your home lab transforms into a zero-cost autonomous agent. Imagine this. An email arrives, N8N securely sends it to your local Ollama instance, the AI reads it, categorizes it, and actually drafts a reply for your review. You can have it summarize your daily RSS feeds at 7 a.m. sharp, or monitor your server logs 24/7 for anomalies. And the best part? It does all of this locally without exposing a single byte of your data to the internet. This is where a local AI stack stops being a cool novelty and becomes a massive productivity multiplier. So, as we wrap up this explainer, you now have the blueprint to take back your data. We've covered the compelling economics, the golden rule of VRAM, the hardware choices, and the software stack to make it run. You know exactly what it takes to build a sovereign, private system. So the only question left to ask yourself is this: are you building your intelligence, or are you just renting someone else's? Start looking at your token usage today and seriously consider making the switch. Thanks for joining me.